Is it bigger than another unit? All right, we're doing number 12. So we have, at what altitude above the Earth's surface is the gravitational field strength equal to G over 9? All right. Ooh, we got to remember what altitude is. What is altitude?
Height relative to sea level.
Height relative to sea level, height relative to the surface of the planet, right? So I would definitely show that I understood, this is 12. Altitude is blah, 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 blah. I would definitely show that I understood that. You know, height above sea level, distance from where you are to the surface of the planet, right? What's creating the gravity? What about the Earth is creating the gravitational field? What does the Earth have a bunch of that would make gravitational field? Mass. So, the mass, I'm going to put stuff, of the Earth creates the grav field. I think on the next one I might try typing, but probably better than my handwriting. Kind of horrible. Because I'm in the middle. Next problem. What else affects the gravitational field? From where? Center of the Earth, and that's important, right? So, Earth. Reduce. I'm gonna say reduces or increases the field. Okay. Let's see. So I know it's about the Earth. I know the mass and how far I am from the center of the Earth is, and I made sure I understood what altitude was. I could do a little picture here, right? If I wanted to, because I've got the Earth here. I've got my little satellite here. What we want to know is, what do you want to call that distance? A, we'll call it A, variable A, out for altitude. Right. And then this would be the radius of the Earth. Right? And our whole distance that we care about is from that center to this. That we'll just call R. Now I could put that here, or I could put it in my house. Or I could just leave it out and hope that I don't mess it up. Either way. Questions before we do the house? Yeah.
Can we just briefly go over the rubric of it?
Sure. Let's check it out. Let's see how I did on the rubric. Clear understanding of the physics in the problem. I think I clearly understand that the mass and how far I am from the center is going to affect the gravitational field. Because that's the physics here. Yeah? Good question. I wonder if it's on any of our references. Let's see. Here's our equation sheet, right? I wonder if it's on that second page. There it is. Radius of the Earth. Cool. I probably also could have Googled it.
Yeah.
Radius of Earth in meters. But what a nice teacher to provide that. But good question, because if I don't know that, I'm stuck, right? Clear links to problem to sketch a roadmap to the how. Is it clear that I'm talking about the gravitational field around the Earth and what influences it? And that I understand that I'm looking for the altitude above the Earth. I think the diagram helps with that also. Did I put any equations in there? Did I say I'm going to solve it this way? No. So I get those 2 points.
So that R on the far left, that doesn't represent radius, that represents the distance from the sun.
From 1 point to 1 point. Now, what do you, if you were to define radius, how would you define it?
The distance from the center of an object to the outside of the circle.
Oh, so it has to be a circle? I define radius as the distance from 1 point to another. Now, the radius of a circle, the 1 point is the center of the circle, the other point is any point on the outside of the circle.
Okay, yeah.
But a radius is just from any point to any point.
Yeah, that makes sense.
It's a different, but you probably were never told in math that radius, they actually meant the radius of a circle, right? So, yeah. And that causes a lot of confusion, I understand. Did I hit the rubric?
How does this explain why the universe works?
Well, I think that it explains that the mass is contributing to the gravitational field. I didn't say, I'm going to plug in mass, which would be explaining how to solve it, rather than that there's a relationship there. Now, could I have gone further and said, well, the bigger the mass of the Earth, the more the gravitational field? Yes. So, probably if I was typing, my hand wouldn't have gotten as tired.
So you don't necessarily need to outwardly say this is why the universe works. It's kind of implied.
Right. Mainly on that one, looking for you to be explaining why things are happening, not how to solve it. That's the how to solve it is the how. Yeah. Right? But in both those, in the middle one and the bottom one, you want to make sure it's clear that you're not just talking about any problem at all about gravity. You're zoomed in on this one about the Earth. Like, I think it's problem 8 or 9 that is about Mercury. At least my copy was.
Yeah.
Same question, but about Mercury.
The only difference between this is that it's mentioning altitude.
Right, that's how this one's different. So that's why, that altitude's in there, and also focusing on that I'm talking about the Earth in this case.
What did they say the altitude was?
That's what we're looking for. Some people define it, I like our first definition, I think it was altitude above, the height above sea level. I think it was the height above the surface of the planet. Yeah.
How would you, I know that gravitational field strength and force gravity is different, but I just don't know how to write about them. Describe differently, you know what I mean?
The gravitational field strength, or the gravitational field, is created by one object, in this case the Earth. Gravitational force is the interaction between two objects. So if we wanted to know the gravitational force on the satellite, we need to know how much mass the satellite had to interact with the mass of the Earth and create the force. The gravitational field at that point is just created because of the size, the mass, and how far we are from the center of the Earth. So that's all dependent upon the Earth. No matter how big the satellite is, it's not influencing the gravitational field strength there. Just like, we'll talk about this when we talk about acceleration and free fall, but two objects, when they're dropped, they accelerate at the same rate, big and small, right? That's because they're in the same gravitational field. They're not creating it, the Earth is creating it.
So it all has to do with one object.
Right. And that's why, and now if we express that mathematically, right, because we should be able to say it in English and math, we go here to our equations, here's our gravitational force, right? Here's our gravitational force. You've got two masses in there. That's the interaction between them. Here's our gravitational field strength. You only have the mass that's creating the field, the one thing. So we said it in English now, that's how you say it in math. All right, so that's the equation we're going to use. So let's get down here to our how. And I'm going to use that the gravitational field strength is universal gravitational constant, how the universe interacts with gravitational influences, the mass of the thing creating it, in this case the Earth, over how far I am from the Earth. And in that problem I put a P on that. We could drop all those P's. Be the same equation. In fact, I'm going to get rid of them just so they don't cause confusion. Those are just to remind you it's a planet. I may even pull them off the equation. We'll see. Alright? That's my valid physics equation. So now I need to substitute in, and I'm looking for the altitude. And as I see from my diagram here, my radius is my altitude plus the radius of the Earth. Because it's how far it is from the center of the Earth to that satellite. So let's plug it. Now, let's plug in stuff. There we go. Gravitational field strength, little g. I know it's 1/9 of what it is on the surface. So I'm just going to put little g over 9, where that little g I know is 9.81 newtons per kilogram. Maybe I'll put that in. How do I know it's 9.81 newtons per kilogram? It's on the equation sheet. It's also on the wall. Yeah, because it's one we use all the time. Now, if you mathematically figure out a newton per kilogram, you can also break it down and write it as meters per second squared. If newtons per kilogram doesn't tweak your fancy, you'll see the book does that sometimes. Big G, look that up on my equation sheet. 6.67 times 10 to the negative 11th Newton meter squared per kilogram squared. I gotta move everything over, sorry. Mass of the Earth. .98 times 10 to the 24th kilograms. Good. So 5.98 times 10 to the 24th kilograms. Oops. That's how it's sticking to my head. Radius, so that's my altitude plus the radius of the Earth. Radius of the Earth, 6.38 times 10 to the 6th meters. Do I want to leave that in meters? Well, yeah, because my gravitational constant's in meters and kilograms, right? So I want to leave it in meters.
You're solving for
Yep. And now I just do the algebra and solve for A. Easy algebra, right? One variable, all numbers. A represents our altitude. Now, let's say you're not that good at algebra. Let's just say. Let's say. Is this an algebra class? No. So there must be, Cochran must provide us with a way around actually knowing how to do algebra. And he does. Right on our links page. I don't know, what does it say on the test? Look at the front cover. What do you think? There are 5 different math solvers right down there. Feel free to use any of them.